Good morning students. Up to the last lecture we have studied the resistors in series. Okay. So resistor if we connect in series, then their equivalent resistance will be equal to the addition of resistors that we are connected in series. Okay. So we see one equation, that is Rs is equal to this equation. Okay. Rs is equal to R1 plus R2 plus up to n. Okay, if n resistors are connected in series, at that time their equivalent resistor will be equal to how much? The addition of each resistor that we are connected in series. Okay, so such a way that by using this formula, in case of series connection, we can find out the final equivalent resistor of that circuit. Okay, we have already studied about resistors. Resistors are what? Resistors are the electronic component that used to resist electric current. Resist means what? To stop down. Okay, to oppose the electric current. Okay, so these are the electronic component which opposes electric current. Okay, so this resistor we can connect by two ways that are also we studied. One is the series connection and second is the parallel connection. Okay, so such a connections we can use resistors in electric circuit. Okay, so first of all we have to know what is resistors. Then we are studied in last lecture resistors in series. Now today we have to see that is the resistors in parallel connection. Okay, so now this topic resistors in parallel that we have to see today. Okay, now in a series, I told meaning of a series. Series means what? In one line. Okay, if all resistors are connected in one line. Okay, in previous diagram, in resistor in a series, that topic diagram we see all three resistors R1, R2 and R3 are connected in one straight line. Okay, one straight line diagram. Okay, so that connection are called series connection. Okay, now here if we observe carefully, we have to see in parallel connection. Okay, parallel means what? Parallel line means what? Two lines that not cross each other at any point. Okay, up to infinity, that lines are simply called as a parallel line. Okay, same way in case of a parallel connection, look at here, this is the first resistor R1, this is second resistor R2 and this is third resistor R3. Okay, so these three resistors are connected in parallel. Parallel means what? These separate three lines are there. Line means what here? This line means what? These three separate electric connections are there. Okay, so here these three resistors are connected in three different ways. Okay, such a way that both three are parallel to each other. Okay, so such a connection are called as parallel connection of resistors. Okay, look at resistor we can connect by two ways. First is series and second is parallel. Okay, in a series connection I already told you all resistors are connected in one line. Okay, now here if such a way that resistors are connected, then this arrangement is called as a parallel arrangement of resistors. Okay, so look at here, R1, R2 and R3, these three resistors are connected in between point C and D here. Okay, so in between these two points C and D, these resistors R1, this R2 and R3 are connected in which way? Parallel way. Okay, so here we connect our voltmeter in between C and D point, that will tell us about the potential difference between the point C and D. Okay, we know due to the connection of this resistor, okay, somewhat voltage potential difference is developed in between point C and D. Okay, to measure that potential difference we have to connect one voltmeter, because voltmeter is used to measure potential difference. Okay, so look at resistors R1, R2 and R3 are connected in parallel in between point C and D. Okay, V is potential difference B, the point C and D. Okay, V is potential difference between point C and D. Okay, now, okay, look at here. Okay, these three resistors are connected by three separate connection in between point C and D. Look at this R1 resistor is connected through this wire. Okay, this R2 resistor is connected by this second wire connection, and R3 resistor is connected by third wire connection. Okay, so these three resistors are connected in between point C and D separately. Okay, so whatever the current flowing through each resistor, okay, that will be different. Okay, because these three resistors are connected by separate connection. Okay, again they will come here. Okay, at that time value of current will be add up. Okay, but as current flowing through each resistor, at that time value of current will be different. Okay, so remember here the value of current through each resistor in parallel connection is different, is not same. In the series connection, what happen? Value of current is remain same. Okay, because all three resistors are connected in one single line. Here all three resistors are connected by three different electrical connections. Okay, so value of current will be different over here. Okay, so here we connect the battery E. Okay, battery E. Okay, so due to that battery, current I is passing through this total circuit. Okay, now as this current I came here, okay, that will get divided into this and this. Okay, so as this current I came here at point C, at that time it will get divided I1, so it will go through this wire. Okay, now again this I divide into I2, so that I2 current will be passed through this second resistor, and I3. Okay, so I3 current will be passed through resistor R3. Okay, so as this electric current came here at point C, it is split into three ways. Okay, I1, I2 and I3. Okay, if you take again here, as this electric current I1, I2 and I3 again came here at point D. Okay, at that time this I will be equal to I. Okay, so we can say that the total current through circuit will be equal to how much? That is the I. Okay, but this I current came here. After that, what happened? It will split into three ways: I1, I2 and I3. So if we take addition of I1, I2 and I3, I1, I2 and I3, that will be equal to this capital I. Okay, so we can write here capital I will be equal to I1 plus I2 plus I3. Okay, so we called it equation number 1. Okay, look at here, simple. You have to see such a connections of resistors are called as a parallel. Okay, they are looking like a parallel line simply. Okay, so this is a parallel connection. So these three resistors are be connected here in parallel way. Okay, R1, R2 and R3. We know in parallel connection current through each resistors is not same. Okay, so whatever the current flowing through this circuit, as it come at point C, it divide into these three ways. Okay, I1 is the current flowing through R1 resistor, I2 is the current flowing through R2 resistor, and I3 is the current flowing through R3 resistor. Okay, so such a way that this total current I is divided into I1, I2 and I3. Okay, so we can write here total current I, that will be equal to I1 plus I2 plus I3, and we called it equation number 1. Okay, now here we know according to Ohm's law, okay, we see Ohm's law, equation of Ohm's law is what? V is equal to IR. So by using this Ohm's law we can derive this equation for current I. So I will be equal to V by R. Okay, that relation actually we have to use here. Okay, so I is equal to V by R. Okay, we have to use that equation. So according to Ohm's law, if you use this Ohm's law for this diagram, okay, so I is the total current flowing through this circuit. Okay, I is what? Addition of I1, I2 and I3, that is the total current, capital I is flowing through this circuit. Now how much total resistance is present now in this circuit? Okay, that is what? R1, R2 and R3. Okay, these are the three resistors which are connected parallelly with each other. Okay, so this R1, R2 and R3 is the resistance of this circuit, but these three resistors are connected in a parallel way. Okay, so their total equivalent resistor we call RP. RP means what? Total parallel resistance. Okay, so current, that is this current flowing through this circuit will be equal to this potential difference V divided by RP, that is the total parallel resistance of the circuit. Now, so by using this relation we can calculate the value of I1, I2 and I3 over here. Okay, so by using this analogy we can say that the I1, okay, that is the current flowing through resistor R1, okay, that will be equal to this potential difference V divided by resistance of this first resistor R1. Okay, so I1 will be equal to this V divided by R1. Okay, look at in between point C and D, this potential difference remains constant. Okay, so here I1 will be equal to this potential difference divided by this first resistance R1. Okay, similarly I2, that is the current passing through resistor R2, that will be equal to V divided by R2. Okay, V is what? Potential difference between point C and D, and R2 is the second resistor. Okay, so I2 will be current passing through second resistor, which is equal to V divided by R2, and third current passing through this third resistor will be equal to this potential difference V divided by this third resistance R3. Okay, because I3 is the current passing through resistor R3. Okay, so by using this simple analogy of Ohm's law, I is equal to V by R. Okay, but total resistance is how much? Total parallel resistance through these three circuit these three circuit. Okay, so I is equal to V by RP. By using this analogy we can calculate the value of current I1, which is passing through resistor R1, I2 which is passing through resistor R2, and I3 which is passing through resistor R3. Okay, so such a way that we can calculate the value of I1, I2 and I3. Okay, so I1 will be equal to V by R1, I2 will be equal to V by R2, and I3 will be equal to V by R3. Okay, so look at I1 is the current through resistor R1, I2 is the current through resistor R2, and I3 is the current through resistor R3. Okay, so by using this Ohm's law we can find out the value of current I1, I2 and I3. Okay, now so we know, okay, what the, if we look at equation number 1, which tells us the total current I will be equal to this I1 plus I2 plus I3. Okay, now we know this I will be equal to V by Rp. Okay, then I1 will be equal to V by R1, I2 V by R2, and I3 V by R3. So we have to put these values in this equation number 1. Okay, instead of I, we have to put this V by Rp. Instead of I1, we have to put V by R1. Instead of this I2, we have to put V by R2, and instead of I3, we have to put V by R3. Okay, so from equation number 1, okay, equation number 1, I is equal to what? V by Rp. So instead of this I, okay, I is equal to what? V by Rp. We have to put here V by Rp. Okay, is equal to I1. I1 is equal to what? V by R1. So instead of this I1, we have to put V by R1. Okay, again I2. I2 is what? V by R2. And I3 is what? V by R3. Okay, so R is equal to I1 plus I2 plus I3. So instead of this I1, I2, I3, we put V by R1, V by R2, and V by 3. Okay, so we have to put these values in this equation number 1. Okay, I is equal to V by Rp, I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. So this equation will become, okay. So now here, if we take V common from right hand side, okay, so this V is here and this V is common, V is present in left hand side. Okay, so this VV will get cancelled, so remaining will be 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this is the equation of this parallel resistance of 3 resistor. Okay, this is the equivalent resistor. Okay, now this is 3 resistor which are connected in common, but their equivalent resistance of these 3 resistor will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this is the equation of equivalent resistors. Okay, equivalent resistance of the circuit when 3 resistors are connected in parallel way. Okay, now suppose if n number of resistors are connected in parallel, okay, then their equivalent resistance will be equal to 1 by Rp is equal to 1 by R1 plus 1 by R2 plus up to how many resistors we are connected? Up to n. So Rn, resistance of nth resistor. Okay, but in reciprocal. Okay, we see in case of series there are equation of final resistance is how much? R1 plus R2 plus R3. Okay, here what? Equivalent resistance, okay, in parallel, that is the 1 by Rp will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so that is the difference in between when we are connected resistors in series and parallel. When we are connected resistors in series, at that time we have to take addition of all resistors. Okay, addition of all resistors. So resistor will be increased, resistance will be increased as we connect or as we increase the number of resistors. But here we have to take reciprocal addition of reciprocal of each resistors. Okay, so in case of parallel connection, resistor decrease, resistance decrease. Okay, if we increase the number of resistors. Okay, so such a way that what happen, resistors are connected in a series and parallel way. This is the equation Okay, this is the equation of resistor when they are connected in parallel way. Okay, so there are two types of resistors. So in the two types we can connect resistor. First is series connection, second is parallel connection. So here we see connection in parallel way. Okay, equivalent resistors when they are connected in parallel. So their final resistors, final equivalent resistance of these three resistors R1, R2 and R3 will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected, then their equivalent resistance will be equal to 1 by R1 plus 1 by R2 plus 1 by Rn. Okay, so such a way that this is the equation of resistance when they are connected in parallel. So next topic we will see in tomorrow's lecture. Thank you.